We're going to start with De Morgan's law. This video, first of all, we'll talk about the first three D laws. Okay, so in De Morgan's law, we can prove it by using the different sets of arrangement of circuits of gates. Okay, so we are going to talk about De Morgan's laws. So the first one states that A dot B whole thing bar is equals to A bar plus B bar. Okay, and similarly, the next one is A plus B whole thing bar is equals to A bar dot B bar. Okay, so how do we prove this? Well, there are two ways to prove this. In set theory, we have different set expressions. Okay, and in Boolean algebra, we have different gates. Okay, so if you draw these two, and find the truth table, actually you can see why it works. Okay, so A dot B whole thing bar means we need a NAND gate. So we have A, B signals, and they are passed through a NAND gate. That's it. Okay, that's what we have on the left hand side. This is equivalent to, De Morgan states that this is equivalent to A bar plus B bar, which means we are passing A through a NOT gate, okay, and then we are passing B through a NOT gate, and finally these two are sent through an OR gate. These two are sent through an OR gate. So De Morgan states that these two are equivalent to each other. So let's look at the truth table. So if you think about it, this is another way of building a NAND gate without an AND gate. Okay, we have two NOT gates and one OR gate to build a NAND gate without even an AND gate. Okay, so similarly here we can prove this also. Okay, so let's draw the diagram. So we have A and B passing through a NOR gate by A plus B whole thing bar. Okay, A plus B whole thing bar. So that's it. That's it. So the output will be, A plus B whole thing bar. This is equivalent to, okay, you passing two signals through a NOT gate and then an AND gate. Okay, so we have a NOT gate here, and these two are passed through an AND gate. Okay, so this is what De Morgan states. This is equivalent to this guy. That is what he says. So let's do that. So we have A, we have B. The same output as we have here. So this is another way of drawing NOR gate, but without using an OR gate. Okay, so if you consider this one really hard for you, just keep in mind, if you have something covered with a bar, okay, if you have something like A plus B whole thing bar, what you have to do is just break this bar. Okay, think of it like this. Okay, you're breaking this bar. So what will you get? You'll get A bar and B bar. Okay, instead of putting plus here, you have to put a dot. That's all the change you have to make. Similarly, A dot B whole thing bar, if it is there, what you have to do is you have to again break this bond or this bar. So you'll get A bar and B bar. Instead of putting dot here, you'll put plus here. That's all you have to do. Okay, if you don't want to memorize all those gates and stuff. Okay, that's it. Now we are going to talk about the double complement law. Okay, the double complement or double inverse law. Okay, double complement law. The name itself is self-explanatory. This is like what if we have double bar? Okay, so let's say we have A double bar. What will the output be? Okay, so this means this is equals to A. That's all. I don't even have to draw that thing, but I will do however. Okay, so let's say we have A here, okay, and we are sending it through a NOT gate. Okay, we are sending it through a NOT gate. So what will you get? You'll get A bar. And if you send it through another NOT gate, okay, you are reversing it back. So it will be A, but let's say this is A double bar because we are increasing the number of bars. Okay, so let's look at the truth tables. So A bar is exactly behaving like, sorry, A double bar is exactly behaving like A. Okay, so this is the double complement law, or we call it double inverse law or double bar, anything. But just keep in mind, A double bar is equals to A. Okay. So here the thing is, keep in mind, just because we are learning about only double bar, it also applies to 3 bars. Okay, so if you have 3 bars, Well, that means this has 3 bars, odd number of bars. So the output will be A bar. Okay. If you have even number of bars, 2 bars or 4 bars, well then the output will be A. Okay. Just keep in mind. The next one. Okay. The next one is we call the distributive law. Okay. The distributive law. Here we are speaking about some of the basic things. Okay. Distributive law. Okay. The basic things. Let's say they're asking you to expand x into y plus z. What will you do? You'll just say it is equals to xy plus xz. Yeah, this is what you normally do when you're performing algebraic questions, right? You just expand things. Yeah, you do the same thing here also. I mean, not you do, you can do the same thing here also. Okay, you can do the same thing here also. So the first distributive law states that a dot b plus c is equals to a dot b plus a dot c. Okay, and similarly, there is another one. If you have something like a plus b dot a plus c, okay, a plus b dot a plus b, a plus c, the output will be a plus b dot c. Okay, I know this is a little bit confusing. Okay, so here let's take the left hand side. Okay, this one is a little bit confusing. So let's start from the left hand side. So we have a plus b, a plus b dot a plus c. Okay. So what we can do is we can expand this. So how do we normally expand this? Well, this can be represented as a dot a plus c plus b dot a plus c. Okay. It's like expanding binomial expression. Okay, I know this is not binomial, but I'm just telling. Okay, then this is equals to a dot a plus c. See here, when we had a dot b plus c, we got a dot b plus a dot c. Similarly, here we have a dot a plus c. So the output will be a dot a plus a dot c. Okay, and then plus we have b dot a plus b dot c. Okay, so that's what we have. So what's the next step? Well, the next step will be, since we have a dot a, do you remember something? Okay. When I taught you in the last video, when we talked about the 3I laws, I taught you about idempotent law. Okay, idempotent law. So a dot a is actually equals to a. Okay, since we have learned about the distributive law, if something like a dot b and a dot c are there, what we can do is we can factorize it, right? It's not factorizing in Boolean algebra, but it's something like that. Okay, you can shorten. So similarly, I am going to shorten it. I'm going to take a out. Okay, so a dot 1 plus c plus b plus b dot c. Okay, so since we have a here, this is 1. Since we have a dot c here, this is c, and this is b dot a, this is b. And if you remember identity law, we know adding 1 with any other signals will be equals to 1. So this is equals to a dot 1 plus b dot c. And again, according to identity law, a dot 1 is also equals to a. So the output will be a plus b dot c. Okay. So instead of doing all these things, you can directly use it without any issues. Okay, don't do all this unnecessary stuff. You can just directly use it. Okay, first of all, just make some write it again and again, draw it again and again, and practice these laws. Okay, don't forget the first 3 I laws. Okay, they are also important. Idempotent, identity, and finally we talked about inverse law. Don't forget about them also. So keep this in mind. We have learned about 3 I's, and then we have learned about 3 D's. Okay, we only have car laws. We have only car laws, and that's what we have to do in the next video. After that, we will do some practice questions. So stay tuned.
Thanks for watching the 8th video in our Logic Gate series. If you found this deep dive into the 3D Boolean laws, De Morgan's, double complement and distributive laws helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master Logic Gates. Follow us on Instagram, and I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.